Hi, so this is Mr. Max. So what we'll do here is linear equations, problems on distance, speed, and time. You will see that these questions are quite tricky, but if you are doing them step by step, make a table, it's going to help you. So I'm going to jump right onto the first question. So I'm going to do about 5 questions on this particular problem. Right, so here we've got Warren walked to town and the speed is given as 4 kilometers and then he ran home at 9 kilometers. So walking and running. Now you must understand whenever he walks, he's a bit slower than when he runs. So that is why you see that the speed obviously is in kilometers per hour is higher here, all right, than the speed when he walks. And the distance we don't have, so I just let it be x as indicated by the question. Now to find time, you divide the distance by x. So it's going to be x over 4 and x over 9 respectively. Okay, so this is how you complete that particular table, and from this table we are supposed to find the distance from one's house to the town. So we have to find x, but we're also told that it took him 4 hours and 20 minutes to get to town and back. Now what you need to understand is that this time here should be in hours. So the best thing is to do before you continue is to make your units to the same. And everything should be in kilometers and kilometers per hour. So the 20 minutes has to be changed. All right, so let me just bring in the information we have. So you change 4 hours, 20 minutes, you just use your calculator. So please, it should be giving you 13 over 3. So make sure that you use your calculator correctly, that you use the mixed number part of the calculator. You put a 4 in the mix and 20 over 60. It's going to give you 13 over 3 hours. So what I'm dealing with now, I am going to find the distance from Warren's house to town. All right, so now I know the time that he walked is x over 4 and the time that he ran is x over 9. That should give me the 13 over 3 hours. All right, everything is in hours, and this is an equation I can easily solve by finding the LCM on both sides. So 4 times 9, the LCM is 36, and 3 times 12 gives you 36. So the reason why I did it in this way, as you have many ways to solve this equation, is I can drop the denominators now, and I can only equate the numerators if you are doing equivalent fractions and they are out of the same parts. Right, so this gives you 13x is equal to 156. X should be nothing but 12. So therefore, the distance then from Warren's house to town is 12 kilometers. Right, so if we look at question 2 here, so I've got a question that says that a man undertakes a journey of 240 kilometers and he travels some of the way by train and by car at X hours, and then the total time uh, for him to complete this was 4 hours. So what I've done here is I've completed my table. So the train is slower than a car because of the speed when you look at the speed that you are given here. The speed of the car is 72 kilometers per hour, which is faster than 48 kilometers per hour. Now, the journey can only be done in 4 hours. That is the constraint we're dealing with. Now, suppose you are struggling this part. Let's say I take a random number and I say x is equal to 1. All right, this is making sense. Then this is going to be 3 here. All right, 4 minus 1. Why I have the 4 minus x on top is because the train is much slower, it takes him more time to complete the journey by train than it will take him by car. So the x I put at the car. All right, but you're also given that information here. Now the reason I'm mentioning that is that we are going to find instances where they don't tell you, like in this case, let x be they completed the journey by car for x hours. But in this particular case, if this is x, then there should be 4 minus x, as everything should just give you obviously the 4 hours. Right, so what I have is, let me work out distance then he traveled by train. Now you should know that distance is calculated by multiplying the speed times the time. So when you multiply the speed times time, you end up with this expression 192 minus 48x. So I do the same for the train, for the car, and it's 72 times x is just 72x. So I have the distance that he traveled by train which is this expression here. I have the distance we traveled by car, which is this 72x here. And I also have the total distance. So that means I can now create an equation. Okay, and once I create the equation, I can solve for x. All right, so you move everything around until x is on its own, and then you should realize that x is equal to 2. Now what is x? It is the hours. Right, the question is asking find the total time, what distance it traveled by train and by car. So we are not done. So we have to find the distance now. Since we know what x is, we can just multiply now. So I'm going to bring in the distance by train as 48 times 2. The 2 comes obviously from 4 minus the x, which we know is 2. All right, simply substitute the x here in these expressions, you should get the answer. And the distance that you travel by car is 72 times 2, which is 144 kilometers. Question 3. It takes a lady 26 minutes to travel 3 kilometers by walking the first part, 6 kilometers per hour, and running the second part, 10 kilometers per hour. What distance does she walk? Now you see here, the time is 26 minutes. So it's best we change that to hours. So what I did is obviously walking is much slower than running because look at the speed, all right, that you can complete. But the time here, right, the time here, remember what I said about that x, we don't know the time it took for her to walk, all right, but we know that we have 26 minutes altogether. So this is why I put my x here, but it's now over 60 supposed to be, and not just x like the previous name. And then what I have here is 26 minutes minus the minutes that we don't know that it took the person to walk, and I get this expression here. So make sure you go back to the previous one and get an idea as to why I'm using the x here. And everything should be over 60 because I'm changing 26 minutes is not a complete hour, it is 26 over 60, and I'm leaving it like that. I'm not simplifying it, all right, because I'm still going to use it. So I mean, I'm going to leave my denominators to be out of 60. So what I have now, if I count or work out the walking distance, the distance is multiplying the speed times the time. And when I multiply speed times the time, I get 6x over 60. This part, please do not simplify it yet. A running distance, if I work it all out, I'm getting 260 minus 10x over 60. That is the 10 times my expression here. All right, so I'm also not simplifying it because I want the denominators to be out of 60. Because the total distance, which we know is 3 kilometers, and I put it over 1 and add the distance that the person walked, which is the 6x over 60, plus the distance that a person ran, which is this whole expression here. All right, so everything all over 60 here, and then obviously you add the numerator there, and you have 260 minus 4x over 60 equals 3 over 1. You can actually do some cross multiplication from this point onwards, and you can solve for x. So x is equal to 20 minutes, all right, because x is for that part 20 over 60. So the question is, what distance does she walk? So that the walking distance we come here, that walking distance is supposed to be 6 times the 20 over 60, and then obviously she walks for 2 kilometers. Right, a fourth question here. Wanda walks at an average speed 3 kilometers per hour for 45 minutes before running for half an hour, which is 30 minutes, at a certain average speed. If she travels a total distance of 6 kilometers, calculate her average running speed. So let me just punch in what I have. And when you do this table, make sure you have distance, speed, time, or the distance must be the first or the distance must be the last, always like that. All right, and obviously the walking distance, walking is speed times time, so 3 times 45 over 60. You have to put it over 60 because it has to be in hours, and that gives me 105 over 60. Leave it like that, don't simplify. And running distance is this x times 30 over 60, which gives me 30x over 60. Again, don't simplify it because we're going to take these distances and we're going to add them and equate them to 6 kilometers, all right, in order for us to find the value of x. Now, once we have done that, you just clean up the equation and you should arrive at x is nothing but 7.5. So we are looking for the average running speed, which is this value of x here. So average running speed therefore is 7.5 or 7.5 kilometers an hour. Again, I suggest you pause the video and make sure you follow step by step. Draw yourselves always a table so that you can fill in the missing information like this, and make sure that you change your hours, your time to hours if it's not given in hours. The last question is John cycles the first 350 of a 470-kilometer journey at a certain average speed and the remaining distance at an average speed of 15 kilometers per hour, less than that for the part of the journey, for the first part of the journey. If the time taken him to travel each part of the journey is the same, and I have put that in red and bolded it so you understand, find the average speed of the second part of the journey. Alright, so I have my table here that I have completed. The first part, 350, he did it in X kilometers an hour, we don't know. But we know that the second part, he did it in 50 kilometers less than whatever the first part was. That is why I have X minus 15. And here you have 120 kilometers that he completed the second part because you're supposed to subtract. And the distance, the time is calculated by dividing the distance by the time. That's 350 over x and 120 over the whole quantity x minus 15. Right, so the time taken is equal. So I'm going to take my 350 over x and I'm going to equate it to 120 over x minus 15 because the times taken is the same, it's equal. So from here, cross multiply, you solve this particular equation. Alright, so you should arrive at x is nothing but 22 and 19 over 23 kilometers per hour. And that is the speed that we calculated. But the question is asking the average speed for the second part of the journey. And this 22 and 19 over 23 is the first part of the journey. So you are supposed to take 22, 19 over 23 minus the 15. Alright, so that gives you roughly about 7.8 kilometers an hour. If you then punch in 22, 19 over 23 minus 15. Right, I believe that you have picked up on a few points here, and remember what I said. You should go back, pause the video, try to work out this solution or these questions on your own, and then compare. Don't forget to subscribe to my channel and also click the notification bell.